design principles, so followed by open close principle, and then Liskov substitution principle. Now we have dependency inversion principle. So there are five design principles, SOLID. So now we are talking about D, that is dependency inversion principle. So what is dependency inversion principle? Okay, let's think about a vehicle. Now, the engine of the vehicle is dependent upon the chassis. So, if we have a chassis ready, okay, then upon the chassis, engine is established. So, engine depends upon the chassis. Now, when engine is established upon the engine, now we have steering, then we have brake, we have accelerator. So now I have a vehicle, means truck or car, four wheeler or two wheeler whatsoever. So now suppose that the chassis, so engine is tightly coupled with the chassis, so it is spanned all around the chassis, and then steering system, brake system, and then accelerator. So they are using engine. Suppose the chassis is changing. If chassis is changing, then engine I have to change. So it is called engine is tightly coupled with chassis implementation. Okay. If I have changed the engine, then I have to change the steering system, brake system, okay, and accelerator system because they are coupled with the engine. Okay, now I am completely habituated. I am accustomed of using that particular accelerator and then with the leg accelerator and brake and then the steering system. So should I change my hand or leg? Means this is nonsense design. Means now if higher level is tightly coupled with the lower level, higher level is if anyone uses something in you can go with our video tutorial on uh, containment where we have composition, aggregation, delegation, okay, and then we have a kind of dependency, okay, usage. So though association, so five things we have discussed. So now if engine is built upon kind of using the chassis, then engine's implementation and chassis implementation. Chassis does not know about the engine, but it is said that engine is dependent upon the chassis, okay, and it is a tight coupling with the engine implementation and chassis implementation. Like that, steering, brake, or accelerator, their implementation is tightly coupled with the engine implementation. Engine does not know about the steering, brake, and accelerator, but they know and they are tightly coupled. So they depend. So steering depend upon the engine depend upon the chassis, body part. So this is dependency in software engineering. It comes at the lowest level if we talk about the relationship in containment, dependency, association, delegation, aggregation, and composition. But still, the dependency is sometimes if I need to replace anything, if I need to modify something, then full system gone for toss. If I need to replace brake, then it's fine. But if I need to replace or do some modification in changes, full gone. Now my brake, my leg is accustomed of this braking system. So now I feel very different if I have changed everything else. So this is bad design. This is supposed to be a bad design. What is dependency inversion? Okay. Now, if engine is dependent upon chassis, so the dependency what we are saying now will invert it, will change it. So engine would depend upon an interface. This is chassis. This is interface. This is Indian. Indian depend upon churches. Indian contains churches. Okay, so Indian depends upon churches. So Indian contains churches. Now Indian contains interface. Indian depends upon interface. From interface, churches is derived. Can you see? Churches is not knowing anything about Indian. Indian contains Indian depends upon churches. This is churches. This is Indian. Indian contains the churches. Indian depends upon the churches. Now, in between Indian and churches, there is a new guy that comes into the picture called interface. Now, Indian depends upon the interface. Churches derives from the interface. Churches derives from the interface, and Indian depends upon the interface. Indian contains the interface. Churches derives from the interface. So now there is a dependency involved. So there is a change in the dependency. Now the Indian dependent upon the churches. Now it changed its dependency direction, and it is now dependent upon the interface. And the chassis, which is not knowing anything, now it is hooking to the interface as per the inheritance relationship, extension relationship. I sorry, realization better would be realization relations. So churches has a new link now, and Indian completely inverted its dependency from churches to interface. So uh, this is interface. This is kind of a dependency inversion. Okay. So now we'll take a kind of other example. Like I have a bridge. So generally we see rope bridge. Rope bridge we have two pillars. Upon two pillars, then okay, so a there is a two pillar, and then from two pillar, okay, so there is a kind of or we can say one bow kind of things will be there, and from there wires will come down. So if this is the bridge, okay, okay, so if this is the bridge, then from bridge there are wires, and wires are, so there are two pillars around the bridge. This is bridge, and there are two pillars. Now from pillars there are kind of wire ropes, and from this pillar now there are ropes. They are now they have pulled the bridge surface. Okay, so this is the architecture. Two pillar, from two pillar ropes are there, and this is the bridge. Then they have hooked the bridge. Now a part of bridge is chain. Okay, or bridge is chain. Bridge become old, and it is chain. And the kind of the wires, the ropes, they were completely connected with the bridge somehow. So full system need to be modified. So we are not talking about only about software. It means in real world scenarios. So if there is a bridge and there are cables, means there are two pillars and cables are hooked up on the bridge. If bridge goes away, so bridge is not dependent upon the cable, but the pillar is dependent upon the cable, and cable is dependent upon the bridge. If bridge is rectified or bridge is changed, then full pillar and cable needs to be changed. Now think about interface. Now the places where the cable is, so this is bridge and this is cable. So this is interface. If there is a specification for the interface, okay, then I can replace the bridge with the another bridge who is following the same interface. Means the where the hooks are nut bolt would be placed. So their gap, so if this is bridge, then both sides of the bridge, the hooks would be. So hooks are placed at same distance, so inner hook distance and across the bridge width. So length of the bridge and breadth of the bridge. Wherever the hooks are placed, all are at equal distance. Their minor specifications all are so interface between the cable. So now we have a new term called interface. So cables of the bridge. So this is bridge. The cable of the bridge. Now they are dependent upon the interface hook interface. Only hooks. Okay, not on the road. So if new road comes in and they realize the same hooks interface, then it can be replaced. So only need to be unbolt, unscrew all the hooks on the road. Okay, take the road away, get a new kind of road. But since cables are dependent upon new with an interface, and road is confirming or realizing the interface, so it will be placed. Like that, if chassis and engine are connected, so engine is now dependent upon nut and bolt. Okay, nut and bolt specification, how nut and bolt are specified, and where they are placed. If engine is depend upon that, and then those nut and bolt are intact, and the chassis, if new chassis come, all the nut and bolt upon which engine is connected, or pulley or gear system where through which the engine is connected, if they are intact with the same specification, new chassis can come. If a steering system braking system or the accelerator, if they are not tightly coupled with the engine, they know one interface. They don't know the engine, so they are connected to the interface. Engine is replaced. New engine will realize the same interface connected. My leg, when it is operating the engine, okay, and my leg when it is operating the accelerator, the interface between leg and the brake or accelerator, if that is the same, so it is my leg is dependent upon the interface, not on the not tightly coupled with the brakes and accelerator and steering, no change. So this is interface kind of program where the higher level is dependent upon the interface and the lower level derives from the interface. So dependency, the higher level dependency, we inverted, we modified, we changed, we rerouted, we redirected. Okay, so this is dependency inversion principle. So please be dependent upon interface, not on a particular class and its implementation. Tight coupling is absolutely not required, not advisable. Okay, now it is understood from programming point of view. So when I am writing a function and function takes the dependent class pointer, if engine takes if engine has methods and method takes the chassis pointer, okay, then now it would not take chassis pointer. So whatever the code is written based upon the chassis pointer. Chassis does not know engine, but in engine methods, chassis pointer comes as a function argument, and their full code is written based upon the chassis pointer. Engine does not know higher level. Okay, so that's all right. If the engine does not know higher level, then it's all right. But it knows chassis. So from chassis point of view, now instead of chassis pointer, it will come as interface I pointer. We can just say I pointer. Now full code will be written with the I pointer. Now I pointer has methods that chassis has to realize. Okay, so chassis derives from I pointer. It realizes all the methods. I would call template methods. And now in the methods of engine, the I pointer is fine. The code is written with the I pointer, but the object that will come will be the engine. So engine A, engine B, engine C, engine D, all derived from I pointer. So we can replace Indian at runtime. So this is highly useful, but it is based upon open close principle in the sense that Indian methods, which is written with the I interface pointers, so they will not change. They are closed for modification and open for extensibility. Now, based upon the I pointer, we have churches. So I pointer churches are there. Churches A, churches B, churches C, churches D. So there could also not, if churches is written means it is come to market. If new churches is required, there churches A is there in the market. Churches B has come. The churches B will realize the I interface pointer and they will be passed to the Indian method. So everything is closed for modification and everything is open for extensibility. They follow Liskov substitution because if I have I pointer, code in the Indian is written with the I pointer, exactly Indian A, Indian B, Indian C, Indian D would substitute this implementation wherever I pointer is. So now we have open close principle, we have Liskov substitution principle. Now we have dependency inversion principle. Which design pattern they follow dependency inversion principle? Strategy design. So strategy design pattern, we write a function and in the function code, we use the dependency. So the if a strategy class is dependent upon a particular class, then that class interface pointer we will use in the methods of the strategy class. And then since the algorithm is completely implemented with the interface pointer, the actual object that we would pass at the runtime would be the realization of the interface any object has done. So this is dependency inversion principle. So nice. Means whenever we write code and a strategy kind of code where in a function or in an algorithm we write complete strategy and if we depend upon some class, then we will use the interface of that class. Based upon the interface we make a strategy and then the actual object that will come through the interface pointer is the classes there who realize, I won't say generalize, realize those interfaces. And now, so the strategy algorithms, they are not tight coupled with the dependent classes, they are tight coupled with the interfaces, we can say, and then interface pointer, we can write the algorithm, we can compile also. But at the time of real working loader, when it starts working, not required at link time also, when loader loads it, at that time we can have the actual object that is derived from the icon. What next? Means this is more, I believe, this is a kind of a gem. We start with the open close, then Liskov substitution. Same thing means more philosophy on it, and then more usage on it. So dependency inversion principle. So I believe we can start using it now only.